Engagement does not result from students' desire to learn. Engagement results from students' desire to do things they cannot do unless they learn. However difficult it may be, our students need to understand fractions. They need to know what fractions mean and how to make them work. Fractions are the necessary foundation underlying algebra, and algebra is the gateway to all higher mathematics. Therefore, we must help our students conquer this mathematical monster. An analysis of the 2006 NAEP mathematics achievement by Mullis, Dosey, Owen, and Phillips found that only 46% of all high school seniors demonstrated success with a grasp of decimals, percentages, fractions, and simple algebra. We know that students learn in many different ways, whether visually, auditory, kinesthetically, or through technology, and I tried to use each of these as I taught my students the basic fraction operations, having a little fun along the way. In order to differentiate between learners, I began the lesson using a PowerPoint presentation to show the process of subtracting fractions. These steps were written on the whiteboard as well, and through direct instruction, I used think-alouds as we went through examples of how to subtract fractions. These ideas were scaffolded as students had previous lessons on adding fractions. They could use this background knowledge to gain insights on how to subtract fractions as well. From there, I had students come up to the board and share their own thinking on how to solve fractions. As a group, we discussed both the successful methods of subtracting fractions as well as the common mistakes students make when performing subtraction. I wrote incorrect examples on the board and asked students to say why they were incorrect. We then solved the problems correctly and came to the steps of solving subtraction problems together as a group. Then I used models and fraction strips to help give students a clear picture of how to subtract fractional parts. I used cooperative learning groups to aid in my students' ability to socially construct meaning according to Vygotsky's principles. To foster motivation, I invited students to compete against each other, and the group that attained 100% would win a candy bar of their choice and the ever-so-popular homework pass. As students worked in cooperative groups, they were able to collaborate and discuss how modeling fractions could help them problem solve. Within their groups, students shared examples and debated answers using the steps we had gained earlier. 2 out of the 6 groups won, with 2 other groups in a close second who had simply forgot to simplify. The next teaching strategy I chose was to use technology to promote student understanding. In order to reach all of my students, I decided to implement playing computer-based educational games to help my students use 21st century skills to learn and apply fractions. I chose 3 different educational games for my students to play: IXL, Fishy Fractions, and Action Fractions. In IXL, each grade level has its own themed game board filled with awards and prizes, so practicing math is like one big treasure hunt. Each time a student achieves a fraction goal, whether it's mastering a skill or practicing for a certain amount of time, they uncover a game piece that helps them on their journey. In the Fishy Fractions game, students add and subtract mixed numbers while racing against the clock and maneuvering a pelican to avoid obstacles to the correct answer. Each game board is leveled and gives students increasingly difficult problems as they go along. In Action Fractions, students must correctly add and subtract mixed numbers in the given time frame in order to fuel their race car. Students go through 4 levels, beginning with like denominators and ending with mixed numbers and renaming fraction problems. As students played the games, their engagement and their learning was astounding. They helped each other, got excited when they answered correctly, all the while practicing and learning the process of subtracting fractions. When giving students opportunity for powerful learning experiences, it is important for students, according to the embodiment theory, to be active participants so they can instill a memory of learning and reactivate that memory in future experiences with the concept learned. As teachers, we can give students cues of important information, vary the pace of instruction through multiple strategies, and design lessons that encourage students to apply the knowledge using real-world examples to foster the learning process. Playing computer-based educational games exemplifies this structure and can be used as a vehicle for student achievement. An example of this achievement is the student who received 5 out of 25 when she first took the subtracting fractions quiz. After teaching through multiple strategies and playing online computer games, her understanding of fractions grew and she attained the highest improvement in my classes by nabbing a 23 out of 25 on her post-fractions quiz. This type of student achievement suggests that the branches of the tree of knowledge can take various routes, and through the implementation of multiple teaching strategies, students have higher levels of understanding. Thus, in changing how concepts are taught, we in turn change what students will discover. The goal of all teachers is to elicit learning in order to shape young minds. Branching out of traditional methods of instruction helps students become responsible learning for years to come. Welcome to 21st Century Learning.